Alright, hi. Today's lecture is Euler Operator Human-Centered CAD Laboratory, March 2009, and this is at Sequel National University Open Course where we are on lecture number 3, Euler Operator, and we are recording. Euler Operator facilitates process adding and deleting face to edge vertex during model modification. Guarantees consistent topology data. Shows systematically how the modeling command is implemented and data structure can be separated from modeling program. Euler Operator continue. Example, the Euler Operator is accepted by Straude, Hilliard, and Braid. You have making edges vertex and kill edge vertex, make edge faces, kill edge faces, make edge kill hole, and kill edge make hole, etc. Euler Operator continue. To change the topology entity allows accompanying changes in other topology entities. Changes in the face can caused by an addition of an edge. Euler Operator continue. Better to manipulate group of topology entities as a group in Euler Operator. 5 independent variables Euler equations. Minimum of 5 Euler operations are needed. Different set of Euler operators are often used with different modeling systems. Your Euler operator used in SNU make an edge, 2 vertexes, peripheral loop, and shell, or kill an edge, 2 vertices, peripheral loop, and shell. So we have over here make an edge, 2 vertices, and peripheral loops on the top, and then back to the kill edges. So if I were to kill it, then this is Euler's operator used in SNU-MOD. Continue. Allocates memory space of the shell. Creates 2 vertex edges between vertex, peripheral loop, and a face empty. Grid geometry is created. You have your make edge double versus the loop in solid, B solid, and this shows edge vertex 1, vertex 2, line 1, surface 1, X, Y, and Z 1, X, Y, and Z 2. Kill edge double vertex loops base solid edge 1 vertex 1 and 2 lines S1 solid 1 and X Y and Z1 X2 Y and Z2 inverse operation use implementation undo operation. Make an edge kill or make kill edge or kill an edge in peripheral loop. Show the make edge be turning into the kill edge on the left. Kill edge be turning the make edge of the ledge. Same thing on the bottom. Euler operators used in SNU-MOD continued. Divided original loop 1 into 2 new loops, loop 1 and 2 update edge connections, and vertex 1 and 2 edge loops are make edge loop base line loop 1 vertex 1 2 edge 1 loop 2 kill edge loop base solid and line loop 1 vertex 1 vertex 2 edge 1 loop 2. Euler's operation used in SNU-MOD context. Make edge vertex kill edge vertex, also shown back and forth as kill edge on the left, make edge value. So these are reversible. Euler's operating use SNU-MD continue. Creating an edge 1 vertex 1 located on loop 1 edge 1 to loop 1 new vertex screw created by the X, Y, and Z edge connection at vertex 1 updated edge 1 is included in loop 1. Make edge vertex base 1 line loop 1 vertex 1 edge 1 vertex 2 K X, Y, and Z kill edge vertex base loop 1 vertex 1 edge 1 vertex 2 X, Y, and Z. Make vertex edge and kill vertex edge and edge continued. Split edge 1 by adding vertex 1 and edge vertex 1 and edge 1 on X, Y, and Z. Edge 1 is replaced with new edges edge 1 and edge 2. Make vertex edge base edge 1 vertex 1 edge 2 X, Y, and Z. Kill vertex edge base 1 edge 1 vertex 1 edge 2 and X, Y, and Z. Euler operators used in SMUOD continued. Make vertex edge base, edge vertex 1, edge vertex, vertex 1, edge 2, X, Y, Z, body, edge vertex, edge double. You have vertex 1, single size of vertex, edge 2, size of edge, tail vertex, vertex 1, edge 2, head vertex, head of vertex, edge, right leg, right arm, right loop, left loop, vertex, edge 1, point X, Y, X and Y, and then vertex 1, point Y and Y, and vertex 1, point Z to Z, edge 1, right arm, edge 1, left arm equals edge 2, edge 1, head vertex equals vertex 1, make edge kill whole loop. Connects vertex 1, loop 1, vertex 2, loop 2, adding edge 1 and base vertex 1, vertex 2, line, loop 1, loop 2, edge 1. Kill edge, kill edge, make loop, base vertex 1 to vertex 2, loop 1 to A2. Make kill edge 0 vertex. Making kill 0 length edge vertex. So split vertex 1 into vertex 2 by adding equation 1. Each edge 1 is edge 1 is created by the belonging to loop 1, loop 2. And make vertex, make 0 length edge vertex base length 1, loop 2, vertex 1, edge 1, and vertex 2. Make edge kill whole base loop 1, loop 2, vertex 1, edge 1, vertex 2. Make or kill peripheral loop, make whole loop. Convert whole loop into peripheral loop. Make peripheral whole, kill whole. Base loop 1, loop 2, kill peripheral, make whole, base loop 1, base loop 2. Application Euler's operators, translation sweeping input points, pi 1 is L is equal to 1, L is equal to 1, or and so to the nth, and with numbers proceeding to nth, the x-plane height of the object. 1 object composed of one edge, edge 1, 2 vertexes, V1 and V2, one loop is created with a making edge, vertex 1, vertex 2, loop, and surface, making edge, vertex, loop, surface. So this is a sweep. It's just basically a line that's been swept into a surface of a round pin. Application of Euler operator translation speech, make an edge, vertex, operation applied in number times 2. So this has kind of been vertex to the line. We've taken the edge, we've taken the line, and we've offset it in bidirectionals. Application Euler operation, make edge loop. So we've taken the loop and we've looped around it. We made edges out of them. Make edge vertexes applied in times. Another way to offset the lines. In the path. It shows the path and makes the edges loop. Application Euler operation transition loop, make edge loop applied a number of times, loop 1, and so to be resolved in loop 1 becomes the loop of the top face. So we've looped this all around. Application of pi I is equal to 1 to the a continuous constant number of the x, y, z plane rotated on the z axis. You have make edge 2 vertexes, loops, sweep, P and P2 with the make edge number time 2. So we sweep this. 2 symmetric profile lines, weighted rate, WRT, Z, X, Y, and Z planes are created by the Euler operation step 1 and 2. 3. Loop 2 becomes whole loop of loop 1 and whole loop of the kill peripheral making whole shells associated with loop 2 is eliminated. Loop 2 is merged with a line loop 1 and make edge kill whole. Make edge loop is applied with a number of times. And then rotational sweeping. So we've had rotational sweeping, and it's kind of vertexal. So make edge apply with the end times to create a rear surface, and then we've looped primitive creation. We have is box with the X, Y, and Z is in the offset coordinated with an H plus. Application Euler's operation primitive creation. We have a body, create a body, width, distance, and height, double the width, distance, height, body shell, loop 1, 2, 3, 4, 5, 6, edge 1, 2, 3, 4, 5, 6, vertex 1 through 8, and the body of the mallocated size of the body. Make edge, double the vertexes, insert sweep, make edge, vertex, make edge, vertex, make edge, loop, make edge, vertex, make edge, vertex, make edge, vertex, make edge, loop. There's 3 different runs in return. Examples of modeling commands: splitting a hexagon. We have 4 make vertical edges, and we've made 4. In B, we've made 4 vertical edges. Now we've made 8 made edges, and then we've split the hexagon into 2 separate shells, and that is splitting the object command. And this was Euler's Operator Human-Centered CAD Lab, March 19th, 2009.